this next slide just shows the proliferation of coaga mussels in Lake Huron, primarily the main basin, with more recent data available throughout the lake. And you can see that the most recent summarized data is from 2017. The darker colors refer to denser populations of coaga mussels. And you can see that through many parts of the main basin of Lake Huron and into Georgian Bay, we have dense colonies of coaga mussels that are filtering the nutrients out of the water column, and that's why the offshore waters in our lake are so clear. The waters are sterile because all the nutrients are being removed by the filter feeding activity of coaga mussels. And you can see that they've increased substantially since the early 2000s. A lot less food for fish to feed on. Speaking of food for fish, Dichroia is a native benthic organism that lives on the bottom. That's not actual size. They're about 1 centimeter in size. And they used to be very abundant in the offshore bottom waters of the lake. You can see that in 2000. Again, the darker the color, the more denser the populations of Dichroia. They are a very important fish food. They're high in lipids, high in fat, and they provide essential nutrients for a variety of fish species. And that you can see that by 2012, they almost disappeared from the offshore waters of the lake. In 2017, you can see that there are a few places in the North Channel of Lake Huron and northern main basin of Lake Huron, and to a lesser extent in southern Georgian Bay, where there still are populations that are hanging on. Right now, we're not sure why they almost disappeared in the first place. It was coincidental with the expansion of coaga mussels. So there's some negative interaction between coaga mussels and Dichroia. So you can see that there's much less food for fish to feed on in the offshore waters of the lake. This is a graph. It's got a lot of colors, a lot of stuff going on here. But the take-home message from this graph is that prey fish, represented by the different colors, the gray and the black refer to the alewife, the non-native introduced prey fish, as well as the smelt, which is the blue color. The smelt were also introduced. So these were non-native prey fish that were very abundant in the lake through the late 60s, through the 70s, into the 1990s. And there's a whole story that goes with those prey fish that I don't have time to tell you about today. But for those of you who like to fish for Chinook salmon, this is a very important part of that Chinook salmon story. The reason why Chinook salmon, which are not native to the Great Lakes, were introduced into the Great Lakes was to control the overabundance of these non-native prey fish. And it resulted in a very popular recreational fishery throughout the Great Lakes, including Lake Huron. Chinook salmon abundance reached its peak in the late 1990s when we had a lot of prey fish. You can see that there's a collapse of prey fish in the early 2000s. What happened there? Well, it's all related to the expansion of coaga mussels, the spiny water flea, the abundance of predators in the lake, and 2 consecutive harsh winters with lots of ice cover. The alewife in 2002 produced a record-sized year class. Small fish, there was no plankton to feed on, so they entered the winter very small, and barely any of them survived by 2003. So we had a collapse of an important part of the prey base at the time, which resulted in a rapid decline in Chinook salmon abundance. Those of you who fish for salmon will have realized that in the early 2000s they almost disappeared. And it was because of all these interconnections of the offshore ecology of the lake being disrupted by invasive species like the coaga mussel and the spiny water flea. So there's a lot less fish to feed on for the large predator fish in the system. I just wanted to show you some of our own in-house data that also corroborates what we saw in that collapse of alewife. This is from our Cape Bridge offshore survey, and I showed you whitefish and lake trout. This is cumulatively all the species that we encounter in our survey. And you can see that in the late 1970s, there were more species in higher abundance. And then we had colonization of zebra mussels. We saw a decline. That record year class of alewife, which is depicted in this color here, in 2002, and then the proliferation of the quagga mussels. And you can see that since 2003, the abundance of all species of offshore fish in this area of southern Georgian Bay is a fraction of what it was through the late 1970s through the 80s. That's how profound the impact of invasive species is. Now, does the general public know about this? This is an ecological catastrophe. But as fish folks, we don't like drama. I don't know, maybe we're just not getting the message out. But it's pretty substantial. It's impacted the commercial fisheries for lake whitefish substantially. Communities, many indigenous communities, are not able to exert their traditional cultural pursuits. Some of the non-indigenous commercial fishers are barely hanging on. So it's having major impacts on not only the ecology, but the economy and the culture of the lake. So what are we doing to try to gain insights into what's happening? I mentioned that lake whitefish are in decline. Why are they in decline? Well, there's very little fish, there's no food for them to feed on. And the plankton is gone. And we're trying to figure out whether during the spring, when there used to be a algal bloom, when you had all this energy in the system, whether that's still occurring. And if it's not occurring, that means that the larval whitefish have nothing to feed on, and they won't survive. So we're doing some surveys in the Fishing Islands area just off the west shore of the Bruce Peninsula. And we know that the Mary Ward Shoal area in Nottawasaga Bay historically was a very important lake whitefish spawning ground. And right now, we're not seeing any reproduction of lake whitefish in that Nottawasaga Bay area. So we're trying to figure out why that's happening. So this is some of the research work that's being done. We're also trying to figure out what's happening with lake trout. I mentioned that over the last 3 or 4 or 5 years, we're seeing a resurgence in the numbers of lake trout. And that's been corroborated by our work in Nottawasaga Bay. This is just a survey area. You can see the netting locations in green. And what we're seeing, especially in the last 2 years, is that there are more adult lake trout showing up on the traditional spawning grounds, and they're actually successfully reproducing. So there's some positive signs for lake trout. Lake trout are reproducing, and some of you may ask, well, why is that the case? Why now? After 50 to 60 years of trying to rehabilitate that species, why are we starting to see reproduction now? Again, the linkages. It's linked to the demise or the collapse of the alewife. So alewife, non-native species, prey fish, very abundant through the 60s and 70s, collapsed in 2003. And that released a lot of native species in terms of their ability to reproduce. You may ask, well, what's the connection? Well, adult alewife are very effective predators on larval fish. So when they were abundant, they would eat all the larval perch and walleye and lake trout that are produced in a given year. When their numbers collapsed, that meant some of those larvae survived. Also, lake trout that feed on alewife develop a condition called thiamine deficiency syndrome, or some would say complex. And some of you say, well, what's that? Well, that is a result of alewife having a very high level of thiaminase in their gut contents. And thiaminase breaks down vitamin B when you consume it. It's an enzyme that breaks down vitamin B. And vitamin B is very important in the normal development of larval fish. So if you have a diet rich in alewife, have very low vitamin B levels, especially in the females, and your offspring don't grow properly, many of them don't hatch. So for decades, lake trout weren't able to reproduce because they were eating junk food, so to speak. They were eating alewife. With the collapse of alewife in 2003, they've shifted their diet. They're eating species of prey that aren't affected by the styminase. So now we're getting this reproduction. But what about whitefish? Well, whitefish is a different dynamic. Whitefish their young aren't getting the plankton that they need. So it's very difficult to convey in a short period of time, in a short story, what's happening with the fish in the offshore waters. So that's what's happening in a nutshell in the offshore waters. Are we ready to go to the near shore? Or are we just totally overwhelmed with what's happening? Okay, and that's just a glimpse into what's happening, but pretty profound what's happening in the offshore. In the near shore, we're not seeing as profound a change in the fish community as we've seen in the offshore. There's some resiliency there, there's more diversity. However, and I probably shouldn't say this right now, the specter of Asian carp, many of you have heard about Asian carp, if Asian carp ever get into the Great Lakes, that whole scenario will change dramatically because of their behavior, because of their reproductive output, and the way they re-engineer nearshore fish habitats. So just keep that in the back of your mind. Right now, we're okay. Although we're not okay because grass carp are now reproducing in Lake Erie. So there's some ominous signs out there. So with that in mind, nearshore assessment. A lot of our nearshore assessment is to characterize the composition and the dynamics of nearshore fish communities. And we're also trying to track the expanding range of introduced species, invasive species like the round groping. So I'm going to give you a cross-section of the program that we embark on to characterize the nearshore fish communities. Now this map shows our nearshore assessment zones, our NAZs. And these are areas distributed throughout the east coast of Georgian Bay up into the North Channel and the North Shore of Manitoulin Island. And I'm going to focus on the Severn Sound NAZ. I wanted you to know that the lake is huge. Like the Severn Sound NAZ would be a large inland lake. And it's distinguished from a large inland lake in that it doesn't have a border. So fish can come in and then they can go out. So it's very difficult to characterize the fish community in Severn Sound as well as the rest of the coast of eastern Georgian Bay. So keep that in mind when I talk about characterizing fish communities in this area. So I'm just going to provide you with highlights of some of our programs. We conduct an end of spring trap netting program in Severn Sound. It's not done annually. We don't have the resources to do it annually. But this is a location where we've done more of these surveys than in any other part of coastal areas of Georgian Bay. It's using live capture trap nets. See the picture at the top right? We attach the lead of the net to shore, and then there's a funnel that funnels the fish into the net. And when we set these nets overnight, we come back and we dip the fish out of the net, we measure them, and we do the biological sampling on them, and then we live release them. So that map on this slide shows you the distribution of netting sites in a typical survey year. So this particular map is from our 2017 survey year. So you can see the distribution of locations that we sampled.